For many years, science fiction has loved one strange idea more than almost any other: the wormhole. These mysterious tunnels through space and time appear in movies, TV shows, books, and games. They allow characters to travel huge distances in seconds, enter strange worlds, or even cross into other dimensions. One of the most famous scientific names for a wormhole is the Einstein-Rosen bridge, a concept that sounds complicated but has captured human imagination for nearly a century. Recently, the popular Netflix series Stranger Things surprised fans by revealing the true nature of the Upside Down. For most of the show, viewers believed the Upside Down was a dark parallel dimension filled with monsters and horror. But in the final episodes, we learned something shocking. The Upside Down was not just another dimension. It was actually an Einstein-Rosen bridge, a wormhole connecting the small town of Hawkins, Indiana, to a distant alien world. That world was the original home of the terrifying Mind Flayer. This twist changed how fans understood the entire story. What seemed like supernatural horror suddenly became science fiction. The gate beneath Hawkins was not magic. It was a theoretical tunnel through space-time itself. So what exactly is an Einstein-Rosen bridge? The idea comes from a scientific paper written in 1935 by Albert Einstein and Nathan Rosen. They were studying Einstein's theory of general relativity, which explains how gravity bends space and time. While working on equations related to black holes, they discovered something strange. The math suggested that space could fold in on itself, forming a bridge between two distant points in the universe. This bridge would look like an hourglass. Each side opens into different regions of space, and the narrow middle is called the throat. If someone could pass through this throat, they could travel enormous distances much faster than light would normally allow. Instead of crossing space the long way, they would take a shortcut. These bridges became known as Einstein-Rosen bridges, and later they were popularly called wormholes. However, there is an important problem. According to our current understanding of physics, wormholes are extremely unstable. The moment they form, they collapse. To stay open long enough for anything to pass through, it would require a strange type of energy called exotic matter, which has never been proven to exist. This means wormholes remain purely theoretical. No one has ever seen one. No experiment has confirmed them, but even though they may not be real, wormholes are incredibly powerful ideas. They offer a scientific explanation for faster-than-light travel, time travel, and interdimensional movement. That's why science fiction writers love them in Stranger Things. This idea is explained by Mr. Clark, the science teacher at Hawkins Middle School. He tells his students that wormholes are theoretical, but they show how science can imagine things beyond current limits. His lesson mirrors real life. Scientists debate wormholes seriously, while storytellers use them freely. Stranger Things is not alone. Over the years, many famous sci-fi movies and TV shows have directly mentioned Einstein-Rosen bridges by name. One surprising example comes from Disney's 1979 film, The Black Hole. While most people think of Disney as family entertainment, this movie was unusually dark and serious. It tried to be hard science fiction rather than fantasy. In the film, a scientist named Dr. Hans Reinhardt plans to fly a spaceship directly into a black hole. As he approaches the event horizon, he mentions the possibility of encountering an Einstein-Rosen bridge. This was one of the earliest times mainstream cinema used the term directly. Another example appears in Star Trek. The franchise often blends real science with imagination. In several episodes and novels, wormholes are described using Einstein-Rosen bridge terminology. These wormholes allow starships to travel across galaxies or into alternate universes. While the technology is fictional, scientific language gives it realism. The TV series Farscape also used Einstein-Rosen bridges as a major plot device. The main character is thrown across the universe through a wormhole, and much of the show focuses on the dangers and unpredictability of these space-time tunnels. Unlike some stories where wormholes are safe highways, Farscape shows them as violent and unstable. Closer to real scientific theory, another famous example is Doctor Who. While the show often uses fantasy-style science, it occasionally references Einstein-Rosen bridges to explain how the Doctor's TARDIS moves through space and time. Wormholes act as shortcuts, letting the Doctor appear anywhere in the universe almost instantly. Even darker sci-fi has used the idea. Some horror science films describe wormholes as gateways to unknown realms where alien physics and life forms exist. These stories often play with the fear that humans were never meant to open such doors. Interestingly, many popular wormhole stories do not mention Einstein-Rosen bridges by name. Movies like Interstellar and franchises like Stargate clearly use wormhole concepts, but they avoid the technical term. This makes them easier for audiences while still relying on the same physics ideas. What makes Einstein-Rosen bridges so attractive is that they sit perfectly between science and imagination. They are based on real equations, real theories, and real scientists. But they also allow writers to break the biggest limits of reality: distance, time, and isolation. In real life, the universe is vast and lonely. Stars are separated by years of travel, even at light speed. Wormholes offer hope that the universe could be more connected than it appears. That idea excites scientists and storytellers alike. Today, researchers still study wormholes mathematically. Some theories suggest microscopic wormholes might exist at the quantum level. Others explore whether black holes could be connected by hidden bridges. So far, there is no proof. But science often begins as imagination before becoming reality. That's why Einstein-Rosen bridges continue to appear in stories, from the Upside Down in Stranger Things to black holes, starships, and alien worlds. Wormholes give us a way to ask a powerful question. What if space itself could bend to our will? Until science gives us a real answer, science fiction will keep exploring the possibilities one wormhole at a time. Wormholes also raise deep questions about time itself. According to some theories, if one end of a wormhole moves faster than the other, or is placed near a strong gravitational field, time could flow differently at each end. This could turn a wormhole into a kind of time machine, allowing travel into the past or future. While this idea is extremely speculative, it shows why wormholes are so fascinating. They challenge our understanding of cause and effect, history, and reality. Scientists take these questions seriously, even though wormholes may never exist in a usable form. Studying them helps physicists test the limits of general relativity and quantum mechanics. These are the two pillars of modern physics, yet they do not fully agree with each other. Wormholes sit right at the boundary between them, making them valuable thought experiments. By trying to understand whether wormholes could exist, scientists learn more about how the universe truly works. Another reason wormholes appear so often in stories is that they solve a major storytelling problem: distance. Space is unimaginably large. Without faster-than-light travel, journeys between stars would take hundreds or thousands of years. Wormholes remove this barrier instantly. A character can step through a doorway and emerge in another galaxy. This allows stories to explore alien cultures, distant worlds, and cosmic threats without waiting generations. Wormholes are also powerful symbols. In many stories, they represent forbidden knowledge or dangerous curiosity. Humans open a door they do not fully understand, and something terrible comes through. This theme appears again and again, from cosmic horror to psychological science fiction. The wormhole becomes a warning about the risks of pushing science too far without wisdom. In contrast, some stories treat wormholes as tools of hope. They allow civilizations to connect, trade, and survive in a hostile universe. They turn an empty cosmos into a network of worlds. In these stories, wormholes are not monsters or mistakes, but achievements proof that intelligence can overcome nature's limits. Real science remains cautious. No telescope has ever seen a wormhole. No experiment has detected exotic matter. Even black holes, once considered purely theoretical, took decades to confirm. Wormholes may follow the same path, or they may remain mathematical ideas forever. Scientists are honest about this uncertainty. That honesty is part of what makes science powerful. Modern research continues in subtle ways. Some physicists explore whether wormholes could exist at extremely small scales, far beyond direct observation. Others study whether space-time itself has a hidden structure that could allow shortcuts under rare conditions. These studies do not promise wormhole travel, but they deepen our understanding of reality. Science fiction, meanwhile, continues to dream. Every new generation finds fresh ways to imagine Einstein-Rosen bridges. They appear as cracks in reality, living tunnels, artificial machines, or cosmic accidents. Each version reflects the hopes and fears of its time. In the end, wormholes remind us of something important. The universe is still full of mysteries. We have learned so much, yet vast questions remain unanswered. Whether or not Einstein-Rosen bridges ever exist, they push us to think bigger, question deeper, and imagine worlds beyond our own.